All right, guys. I hope you guys are having a wonderful Wednesday so far. Today, we're going to go ahead and get right into our lesson, which is the line of best fit. So the objective here is scholars will be able to describe the linear relationship between two numerical variables using line of best fit with at least 80% mastery. All right, so let's go ahead and look at this graph here. As you can see, I have my y-axis here, my x-axis there, and then I have a straight line drawn where I could easily point out what the points are on this line. I know that this line is linear, and I can tell that it is also positive. Now, let's look at this same graph with the same numbers. The only difference here is that I've included homework completed at the bottom on the x-axis and then test scores. So this basically is saying that the more homeworks that a student or a scholar do, the higher the test scores are going to be. So if someone had completed 2 homeworks, it looks like their test score would be about 28. Somewhere along those lines. Okay, so the thing that you could do is how you find that out is you would draw a line going up from 2 and then over, and then that would tell you that if they did 2 homeworks, that their test score would be about a 28. So when you're looking at a scatter plot here, we can also tell that this would be a positive because it is still going in an upward motion, just like that line on the previous slide was. However, we have some points that are kind of like all over the place. So when we look at points that are all over the place, we call these outliers. Outliers are points that are not necessarily not a part of the line. They are a part of the data. However, they kind of like stand out on their own. They're not technically ordinary. So they really don't have any heavy influence on the actual line that will be drawn. So let's go ahead and look at this line here when we're drawing the line of best fit. So this is the same data. We still have the same outlier here, but the point of it is saying what line would look best or what would fit more for this scatter plot data. Like where would the lines go through? So when we look at that, this is a positive correlated line. This would be the line of best fit for this data. And it's not quite a perfect one. So it would be very close to it. So that's when using the equation go into play. But basically, when you're drawing the line of best fit, you really want to just draw a linear line that would be more fitting for the data that you're using. So for instance, when 4 homework assignments are completed, a grade of 50 is expected. How do we do that? We simply just you could take a ruler or draw a line and say if I go to 4, which is the homeworks on the x-axis, and I go all the way up and stop here and then go over, that will correspond with 50. So if you do 4 homeworks, then you'll get a 50 on your test. So basically, the question that we like to ask is, how do you observe data to predict unobserved data? Let's put that question here so you'll see what I'm saying. So how do you use observed data to predict unobserved, I can't spell, data? That's the question at hand. How do you use observed data to predict unobserved data? So the observed data in this situation are the plotted points. We've already observed what that data is, and we observed it by probably plotting the points ourselves from a table or by just getting a graph and it's already plotted for us. And we just kind of look at it and really think about what the variables mean and what are the corresponding numbers with those variables. So for this, the x-axis is homework completed. So we have observed that data. We know that if 4 homeworks get completed, then a student would possibly get a 50 on the test. So we're predicting that if you do 4 homeworks, you get a 50. If you were to do, let's say, 6 homeworks, it looks like you might get like a 62. All right. So how do you use observed data to predict unobserved data? So let me go ahead and clear that off. So now let's look at this one. Let's say we're gonna observe how the hours of TV watching affect your test scores. So if you look at this graph, it looks like it's trending down. So that means this will be a negative correlation. So watching TV a lot can negatively impact your test scores. When you're looking at this, the y-axis here, and you see that the intercept for this would be 0. So if you watch 0 amount of hours for TV, you're most likely going to get about between a 91 and a 100 on your test. But the more TV you watch, the less your score is going to be on your test. So that's how we're going to use that observed data to predict unobserved data. So the more hours of TV you watch, the less you score on your test. So that means it's trending downward, and it's going to be a negative correlation. And then when we're thinking about drawing a line of best fit, you see that this line is pretty much in between all of this data. So that would be the line that fits the best for this data. Now, for that portion, we use the line of best fit, also known as a linear model. So remember, it's a linear line to predict unobserved values. Now, how are a scatter plot, a line of best fit, and an equation all connected? So I believe Ms. Cruz did this in her lesson yesterday a little bit, where we already went over slope-intercept form, which is y equals mx plus b. So let's go ahead and write that. Y equals mx plus b. All right. So when you look at this line or this graph here, it already shows you the line of best fit. It gives you the scatter points, and then this one already have given you what that line looks like. But how did they find that line? So we know that this y equals 1.8x plus 8 is y equals mx plus b, just in that form. Now, before we go into that any further, let's look at this graph here. So when we have a graph and a line graph on it, and we're looking for a slope-intercept form, we first have to look at the y-intercept. What is the value of the y-intercept, right? So we look at the value of the y-intercept, and how do we find that? It is the point where x is going to be 0, and the number or the line crosses the y-axis. So if you see here, it has an orange dot. So this line is crossing over the y-axis, and the value of x is 0. So if you count up 1, 2, 3, 4, so that's why we have 0, 4. So that is our y-intercept. That's the first step. The next step is to find the slope. We know slope is rise over run. Slope also means the rate of change, which can be considered the steepness and the speed of the line and how it's changing. So we know rise over run. So we first start here. Now this one, I put arrows that are going over up, but you could always go up and then over. So let's go up 1, 2, 3, and then 1, 2, 3, 4, 5. So that means my slope would be 3 over 5. So this graph here says student scores. So the amount of minutes that they studied, their points would increase. As you can tell that this is a positive slope. So the correlation from the amount of time that you study to your score is positively correlated with one another. So now let's look at how could we calculate the line of best fit. All right, so first, let's go ahead and see where about, if we were to draw a line from here to here, where about would our y-intercept be? And it looks like it would be around about 47. So let's say that's where we're going to put our line at. All right. So if I know that my slope needs to be calculated and my y-intercept, I'm going to use y equals mx plus b. So because I said my y-intercept is about 47, I'm going to substitute that for b. Now I need to figure out what the slope is. So let's go ahead and put slope here. And slope equals rise, I'm going to do slash run. All right. So let's look at our slope. So from here, we're going to go over to our next point. So if this is 0 minutes, it looks like we could go over to about, let's just go over this one, to 5, from 0 to 5 minutes, right? And then we're gonna go up. So 47 to about 61. So let's calculate that. So my rise would be 14 and my run would be about 5. So we can't simplify that to be a fraction. Well, there's no way to simplify that to be a fraction. So we could just put it in our calculator and get 2.8. So because my slope is 2.8, then my line of best fit will be 2.8x plus 47. So that means for every 2.8 minutes, a scholar is, for every 2.8 minutes, a scholar is getting about 47 points. All right, so there is not a Delta Math or anything like that today. Please go ahead and finish your exit ticket. And if you have any questions, let me know and we will go forward from there. If you're confused about anything, also let me know. And I can clear up any misunderstandings. Have a great day. All right, so I am back one more time because I showed you on the PowerPoint that if you already had a graph, how you would predict the line of best fit by just looking at the graph and kind of guesstimating. But if you needed to have a more accurate answer, you could use a graphing calculator. And the one that I know that we used in class before was Desmos. So this is what Desmos is. So right here, I have my table. I just came up with some random numbers and the random numbers were plotted for me. And this is my scatter plot. Okay. And in order to figure out the line of best fit, you could look at this scatter plot and draw your own line if you had physical paper and pencil and predict what the line of best fit would be by doing it y equals mx plus b and figuring out all of those components. Or you could put your information into Desmos like this. So even though I've already created this table, I'm going to show you what I did. So I pressed the plus button and I did table. Now automatically x sub 2 came up. The reason why x sub 2 came up is because I already have an x sub 1. But most times, if you don't have a table already put up, it'll be x sub 1. And I would type in whatever numbers or whatever, and it would plot, and then I would do the same thing over here, okay? Once I've typed in those numbers and I get all of my plots scattered, then I'm gonna I'm gonna press enter and I'm gonna get another slot, which is right here. And I'm gonna press an expression, okay? Or you can hit the plus button and say what you want, an image, folder, note, expression, whatever, but right now we're doing an expression. So I'm gonna do Y and shift in the little squiggly line, which is approximately equal to M Y1, I'm sorry. And the reason I'm doing Y1 or Y sub 1 is because that's what that is what is what here. If I were to put, if it were Y sub 2 here, I would have put Y sub 2 here. All right, MX sub 1, then plus B, okay? So with me doing that, now I can look at what my line of best fit would be here, okay? So basically my slope here is 0.597938. You can round that. And my y-intercept here is 6.2268. And you could also just round that. I would round it one decimal place over, but that's a, so yeah, if I were to write what my line of best fit would be for this particular one, it would be y is approximately equal to 0.59 x plus 6.2, and that would be my line of best fit. All right, now I think I'm done for real this time. If you have any questions or concerns, let me know. On your exit ticket, if you have a table with data and it asks you what is the line of best fit, if I were you, I will go into Desmos. This is the website right here. And I will put that data in the table and get the most accurate line of best fit that you can choose, okay? All right, have a wonderful day, for real this time.